Welcome back, everyone. In this video, we're going to talk about serverless functions. In order for us to understand serverless functions, we need to go back to our example of our front end with this back end, which we completely own, where we have to provision our own resources, scale up our servers, either horizontally or vertically, and all of the complexity that comes with managing this, which, as we discussed, is a costly from a time and a money perspective ordeal. This is where typically most platforms will utilize something like a cloud service. Cloud services are essentially infrastructure as a service, which means that you are paying a company like Google with their GCP, Amazon with their AWS, or Microsoft with their Azure. These are massive, massive companies that have a ton of these server resources, these physical resources, which have both the RAM, the memory, the disk, the database, all of that resource available. What they also do is they will build out a lot of these toolings and services that we use and the infrastructure to support it when it comes to building a backend. So what essentially happens is that they are now able to scale up horizontally for you or vertically. All that's happening now is when your front end makes requests to the cloud service knows roughly based on the amount of requests that it's getting, how much to provision for you. And you just pay for what you need. This is an incredible time and money saver. And this is why cloud services are exploding right now and have been exploding for such a long time. So let's simplify this by talking about serverless functions. When it comes to usual backends, you're writing Express servers, Node servers, Ruby servers, Rails servers, whatever it is that you're writing, there are numerous flavors of how you can write a server. But this is a lot of complexity because these servers are probably most likely constantly up and running. In our particular case, with a lot of what we need from a backend, we really just need that security layer and maybe access to some of those backend libraries to be able to make a request for us, and then that's it. Maybe the length of the request lasts 5, maybe 10 seconds. Anything after that, it doesn't need to continue to live. It serves a singular purpose. This is where serverless functions step in. And what I mean by a serverless function is it's essentially a function that lives on the cloud, and this function performs that single responsibility. It spins up, it does its responsibility, and then it's done. This is where you can talk about different functions, such as a function that essentially makes a backend payment. It receives a request, it has an amount on it, it makes a request to make that payment for that amount to some other service due to the fact that it lives on the backend, it being more secure now, and then it sends back the response to the front end, it's done. That function has finished its duty, and now it dissipates. You can imagine there are many API requests that do similar things. You can imagine that there is a send email, where essentially we send our backend function some email address and then some body text, and then the email service function just takes that information and then fires the body to the appropriate email address, and that's it. This is essentially what serverless functions are. It lives on the cloud service that has these near limitless resources, and it will generate and spin up these functions whenever they're being requested. Now, each of these functions lives on an endpoint, so it's still like an API that you interface with, but the thing is that behind that endpoint lives just the service's function, not necessarily an entire server. So let's discuss about how this works. The cloud service has access to all the functions that we give to it, essentially the services that we need this cloud to provision for us, these functions. So what happens is that a front end might make the same thing, where it makes a bunch of requests to our cloud service. We might receive 100 payment requests per minute. In this case, the cloud service sees, oh, I need to spin up some of these resources in order to host this make payment function. And then here what happens is that all of these requests go to this resource that has access to these functions. It spins up these functions make these payments for each of these requests, and then it sends back a response, and then it's done. And then the service will now downgrade and get rid of all of the provision resources the moment the requests stop coming in. If we start getting a ton of payment requests, such as 10,000 of them per minute, then again, the cloud service will spin up a corresponding amount of resources in order to provision a duplication of these functions over and over again for each of these different requests. Again, these requests handled and then responses sent back. And then it spins down the service whenever, in a similar way, the number of requests go back down. So it's essentially what you can imagine with having to spin up your own servers. But here we're relying on a cloud service to spin up and down the number of servers or the amount of resources so that we can primarily just host our functions. So this is essentially how this process works. But you can imagine also from a front end, we might be receiving a bunch of different requests. Maybe we got 100 payment requests per minute. Let's say we receive 3,000 API requests per minute and then 5,000 email requests per minute. Now, keep in mind, each of these requests are requesting a specific endpoint for a specific function. So here our cloud service knows that, so it will correspondingly provision the right amount of resources to service the amount that's coming in for each. So let's say there is arbitrarily 1 unit of make payment services in order to handle the amount of requests for the make payment function. Of course, there will be more for the API requests. So again, the service will provision enough resources to handle the 3,000 API requests from the function. And then, of course, the send email takes the most, so it will provision just enough there as well. But the key thing is that it will scale up and scale down for the corresponding requests for each function. And each function gets the amount of servers that it needs in order to handle this type of request. So this is essentially what we're combining together. We know that from our front end, we need to make payment requests to Stripe. So what we're going to do is we are going to write our own serverless functions and host them on Netlify. Netlify is then going to provision the resources for us so that we can actually make Stripe payments. And that is what we are going to do. So now that you understand the high-level concept about why we need serverless functions and how they're going to help us, let's jump into the code in the next video where we can start figuring out how to interact with Stripe. I'll see you in the next video.